essay. Welcome back. So we are moving right on. We have 6.1. We're going to do part 1 and then we'll do part 2. So we're doing rational exponents and properties of exponents. So remember that's also like powers, right? 2 raised to the power of 2 or something like that. So our key terms are rational exponents. It's just another way to express what's called a radical, all right? And then we have product of powers. It's when you multiply 2 terms with the same base, add the exponents. So it's something like if I had 3 to the 2nd times 3 to the 4th, it's really the same as 3 to the 2nd plus 4, which would get me 3 to the 6th. Okay, and a radical, we'll just put that in there. It's this kind of symbol, and sometimes we have a little number in it. These are called radicals. So it's another way to express these, but these are radicals. That's a really bad arrow. There we go. All right. So we're going to use radicals using rational exponents. So it says, what does 3 to the half, this is an exponent or a power, so what does 3 to the power of a half equal? So what we do is we take our base, we have m over n, and it's the same as taking our denominator and putting it in front of my radical, and taking my numerator and putting it inside my radical. I also can write it like this, where I put that numerator on the outside, okay? So if we did that, we would have 3, right, there's my base, right, my radical, my 2 goes here, and my 1 goes there. Okay, another way we could write that is we could do the parentheses version, right, squared here, and then the radical out here. Okay, now anything raised to the first power is just that thing. So really when I do raise something to the first power, it just becomes that thing. So this one can change to this, and this one also, if you notice, whoops, will change to this. 3 to the first power is just 3. Okay, so there it is. And then this whole thing, this is called the square root of 3 raised to the first power will be the square root of 3. The other way you'll see this is you actually won't see the 2 sometimes. That's a really bad radical sign. Hold on. You'll just see it written like this. So this is our square root symbol. Okay, it's called a square root. And that's the one with the little 2, but you won't see the 2, okay? Alrighty, so it says write a radical. So just like we did a second ago, maybe pause and see if you can do this one and see how it goes. And then you can see if yours matches mine. All right, so I'm going to take my base, which is that 5. I'm going to put it inside the radical. My denominator becomes right there on there. You can either put your numerator on the inside, or we can do the parentheses version and write it like this. This is the more common way. This is how the way I would normally do it. The other way to clean this up is to actually square these. So we would do this is called a cube root because it's a 3 cube root, and then we would write 25 because 5 squared is 25. This will actually come out the same thing because we'll have cube root of 5 times the cube root of 5. Okay, and then when we put them together, we get that cube root of 25. Okay, because of that same similar base situation. Excuse me. So this is the more common way, but both end up with the same answer. So it says write a rational exponent. So now instead of writing it this way, they want us to write it this way. Okay, so instead of using this root symbol, they want us to use fractional exponents. So my base is 7. Remember, the number on the outside is my denominator, and the number on the inside is my numerator, and we're done. So it's a lot easier to go from here to here, so from radicals to rational exponents, than it is to go rational exponents to radicals. All right, so this is product of powers. It's where we have the same base. See how they're both a base of 3. And that means we can then take these exponents and add them together, okay? And it's telling me that this product is the same as 3 to the 9th power, okay? So what it's gonna look like is we're gonna do 3, and then I'm gonna do x to the 2nd plus x to the 3rd. Okay, just like we did when I had it as 2 to the 2nd power and to the 4th power at the very beginning, we just add them together. Now we do have to add fractions, so we have to remember that when we're adding fractions, we have to have a common denominator. So I'm going to times this by 2, and this one I'm going to sneak in my little 3's and get a common denominator of 6. So it's going to get me 3 to the 3x over 6 plus 2x over 6. Now that they're a common denominator, I can actually add them together. So I'm going to get 3, hold on, I'm going to scoot that 3 down. 3, and then I add these together, right? I add my numerators, so 3x's plus 2x's is 5x's, and then I just keep my numerator, the denominator the same. And so now what it's saying is this is the same as this. Since we have the same bases, the exponents then have to be equal. So what we're going to do is, now that we have it all cleaned up and combined, we're going to take just the exponents. I'm going to go 5 to the x, 5x divided by 6, and we're just going to set it equal to 9. The bases are the same, which means the exponents now have to be equal. So I'm just going to worry about my exponents. We have to treat this like an equation. So I'm going to multiply by 6 to both sides first. That way it removes this denominator. I get 5x equals 54. And then I'm going to divide by 5. And we would say that x is 54 fifths. All right, so the only way, if you can't read that, that's really bad. Let me fix this. The only way we can say that this is a true statement is if x is 54 fifths. Okay. All right. So we got a common base, and then we just solve them as though the exponents are the only things that matter. All right, let's try another one. So same thing, common base, we already have it. And since it's a product of powers, we can add these and once we clean it up, we can make it equal to this. So we have 8 to the negative x over 2 plus negative x over 3. So same exact denominator needs to be made as last time. So we're going to go times 3 times 3. And then I'm going to times these by 2. We'll get 8 to the negative 3x over 6 this time, plus negative 2x over 6. And that's going to get me 8 to the negative 5 over 6. And remember, that's going to equal 8 to the negative 2. So now that my bases are the same and everything is combined and cleaned up, I'm going to just set the exponents equal to each other. So negative 5x over 6 equals negative 2. So I'm going to times by negative 6 this time. Now the reason I'm going to do negative 6 is that way I get rid of this negative, right? A negative times a negative is a positive. And I get rid of the 6's, because a 6 over a 6 is just 1. So I'm going to take two things at once this time. I'm going to get negative 6 over here. So I'm going to have 5x over nothing. I got rid of that, right? Negative times negative is positive, equals positive 12. Negative times a negative. And then I'll divide by 5. And I'm going to get x equals 12 over 5. All right, let's try another one. All right, maybe this time you try this one without me. So push pause and see if you can do this one without me. And then see if your answer comes out the same. All right, so 2x to the 4th plus 2, oop, nope, I don't need the 2 there, x to the 6th. Hopefully you change these to 12s. So 2 would be 3x over 12 plus 2x over 12. And that would get me 2 to the 5x over 12. And then that's going to equal 2 to the 3rd, right? Because I times this by 3, and I times this by 2. All right, so I'm going to go 5x over 12 equals 3. We just times by 12 over 1 to get rid of that denominator. Gets me 5x equals 36. Divide by 5, and we get x equals 36 over 5. All right. So that's it. Just remember when you have the same base, so a to the 5th times a to the 8th, we get a to the 5 plus 8, which equals a to the 13th, right? So it's the same as like if we can get a to the b times a to the c equals a to the b plus c. It's kind of more of a generic version of that. All right, so here's your independent practice. Try it out, and we will talk about it when we get back to class. All right, until next time, adios.